Today we're going to talk about the slope, midpoint, and distance formula. We have used the distance and midpoint formula earlier in the year, so it won't be too bad to go over and talk about those. But we haven't really used the slope formula, but you might remember it from Algebra 1. And once we look at it a little bit, all that might come back to you. So first, a slope of a line, it is a rate of change. Rate of change in a linear function. So if we have a line and we want to know how much that line is changing, or what rate does it increase or decrease by, that is your slope. So anytime you see the word slope, you need to think rate of change. Anytime you see the phrase rate of change, you need to think slope. And in a graph, we talk about the slope as your rise over run, where your rise is how far up or down you go, and your run is how far left and right you go. So if you're going from one point to another, you can count how far up or down, and then how far left or right, and that will be your slope. If you move down, your top number will be negative. If you move to the left, your bottom number will be negative. So a positive slope has a line going up and to the right. An example of a positive slope could be like 3 over 4. Another example of a positive slope could be negative 5 over negative 2, because a negative divided by a negative is equal to a positive. A negative slope goes down and to the right. So an example of that could be negative 2 over 3, or or 7 over negative 5. So it doesn't matter which number is negative, the top or bottom, and you will have a negative slope. A zero slope is a horizontal line. So that goes horizontally. And an undefined slope is a vertical line going up and down. So when you are looking at a graph and trying to calculate the slope, it's important to understand which point you're going from. So here, it says think of a triangle from A to B. Okay. So if we're going from A to B, we're going down 3 and back 1, 2, 3, 4, 5, 6. So you went down 3. That's where this comes from. And left 6, so that's where this negative 6 comes from. And when you simplify that fraction, you get 1/2. Well, what happens if you would have gone the other direction? What if you went from B to A? So if you went from B, you go up 1, 2, 3, so positive 3, and right 6 plus 6. So you get the same answer. I personally like always going from left to right. It's just easier because I'm left-handed, and I can move my hand across the screen from the left side to the right side. So let's look at some examples here. Find the slope between points A and B using the definition rise over run. So we saw it doesn't matter if we go from B to A or A to B. So we're going down. We went down 1, 2, 3, 4. We're going right. 1, 2, 3, 4, 5. So my slope will be -4 over 5. Letter B, notice that we're going by 2's on the y-axis. Look at that, 2. So we're going down, 1, that's half, and then 2. So for a total of 3, because each box is 3. So we went down 1 first, and now we're going to go down 2 more. So 3, 5, 7, 9. So we went down 9, and we're going right. Well, we're going by 1's when we go in the horizontal direction. So 1, 2, 3, 4. So our slope is -9 over 4. Then letter C, we're not going up or down at all. So we don't have a rise, but we're going to the right 1, 2, 3, 4. So our slope is 0 over 4, or 0. So what if you can't count from a graph? What if you're not given a graph, or what if you're given points that are well off a graph? We have something called the slope formula. And the slope formula is subtracting the two y-coordinates of the 2 points on top. And then on the bottom of your fraction, you're going to subtract the 2 x-coordinates. So if we wanted to find the slope of these 2 points, okay, it doesn't matter which one you make x1, y1, as long as you stay consistent. You can't call this x1 and this y2. There's got to be x1 and y1, or x2 and y2. So you can see that they're plugging in the values here. And when you first start using the formula, it is incredibly useful to write out the formula for a little bit, and then you won't need to, because you'll have it memorized. So when you simplify this formula here, it reduces to 1/2. It also might be a good idea to have highlighters out or colored pencils to kind of color code things as well. When we talk about parallel lines and perpendicular lines, there's something special about those slopes. Parallel lines have the same slope. So if the slope of line L is 3 over 5, and the slope of line R is -6 over -10, you may say, well, those aren't the same, so those lines aren't parallel. However, line R would simplify to 3 over 5. So since these match, lines L and R are parallel. Now, obviously, you would calculate, if you were just given points, you would have to calculate the slopes first. I just wanted to show you what that would look like to have the slopes that are the same. That one doesn't usually give people any issues. It's the perpendicular ones that give people issues. And unfortunately, that's the one that we're going to be looking at the most. So perpendicular lines have opposite reciprocal slopes. So what that means is that you flip the fraction and change the sign, going from negative to positive or positive to negative. So if I had a slope of 2/5, the opposite reciprocal would be 5 over 2, but we make that new slope negative. If we had negative 7 over 4. That would become 4 over 7. We change the negative sign, and you're good to go. Some people get a little bit confused because they think that this negative only applies to the 7. So then they'll change the 4 from positive to negative and say, well, there you go. I changed the sign. Or they may do that over here in the first one. They may make both of them negative. But remember, if you change them to both be negative, it really means positive. So you aren't changing the sign of the slope. You're just changing one of the signs of the numbers, not the overall slope. If you typed in this in your calculator, you get a positive number. If you type in this, you get a negative number. That's what you want. Opposite reciprocal means you look at the sign of the whole fraction and change it. So let's look at the next page. And we're going to tell whether these lines are parallel, perpendicular, or neither using the slope formula. So let's start with the slope of line 1. And we can y2 minus y1. Let's write these out. And then you can label your points. So y2 is 4 minus y1 is 0 over x2 is 7 minus x1, which is 1. So we get 4 over 6, which is 2 over 3. So then we're going to do the slope of line 2. Same thing. Write out our formula. And x1, y1, x2, y2. So y2 was 9 minus y1 is 0 over 3 minus 9. 9 minus 0 is 9. And 3 minus 6 is 3 minus 9 is negative 6. So that will reduce to negative 3 over 2. So if I look at those 2 points, those 2 slopes, it doesn't matter which one you start with. I could look at my blue one right here and say, well, if I flip the sign, if I flip the fraction, 2 on top and 3 on the bottom, and I change the sign from negative to positive, do I get what I have up here? And the answer is yes. So these are perpendicular lines. And like I said, this one is the hardest one to see, is perpendicular lines. All right, for letter B, I'm not going to write out the slope formula in my work, but we'll just go line 1. Line 1, I have x1, y1, x2, y2. So negative 2 minus 1 over negative 7 minus negative 3. So negative 2 minus 1 is negative 3. And negative 7 minus negative 3, well, minus a negative you're adding, so you can think of it as negative 7 plus 3, you get negative 4. So that will simplify to 3/4. You don't have to do that. To me, it just looks ugly having 2 negative signs. It's just a personal preference to do that. Line 2, we have 4 minus negative 1 over 8 minus 2. So 4 minus negative 1 is going to give us 5. 8 minus 2 gives us 6. Those are not the same thing. So these 2 lines are not parallel, and they are not perpendicular either. So for letter C, I want you guys to try that one on your own. So pause the video, give it a try, and then once you're done, unpause it and see if we get the same answer. All right, so if we look at my work here, I got that line 1 has a slope of 1/3 and line 2 also has a slope of 1/3. Because it's exactly the same, these lines are parallel. Now let's look at here, the midpoint and the distance formula. Again, you guys have practiced this and used this before. So what I'm going to do is I'm going to do the midpoint for A and the distance for A. And then I'm going to have you try B for both of them just to see if you still got this. So I have the midpoint formula written up above right here. So we're just going to plug in our numbers. So -7 plus 1 over 2, comma, 1 plus 5 over 2. -7 plus 1 is 6. -6 over 2, comma, +6 over 2. So then that will simplify to -3, comma, 3. So that is your midpoint between these points. Then for your distance, x1, y1, x2, y2. And for now, let's just do the decimal approximation if we need to. That will make it a little bit easier for now. So then we'll have the square root of x2, so 1 minus -7 squared plus 5 minus 1 squared. So again, I'm just going to type all of this in my calculator and not accidentally make mistakes. So parentheses 1 minus -7 squared plus 5 minus 1 squared. And you get 80. Oops. So then let's do the square root of 80. We get 8.94. All right, so pause the video and try letter B for the distance and letter B for the midpoint, and we can see what we got after you try those. All right, so you can see that for the midpoint, I got 5 over 2, comma 5 for my midpoint between those 2 points. And then for the distance down here for letter B, I got 9.2. So hopefully that this last part was a good refresher, and you're going to be able to apply that to these parallelograms that we've talked about before. So thank you for watching. Please like the video and subscribe.